Today we will be going over lesson 1.04, Scott's workout. This is in Unit 1, Sequences. So today's objective is given an arithmetic sequence. We talked a little bit about that last week. What are arithmetic sequences? I can accurately write the common difference and a corresponding function in two out of two problems. You'll notice the common difference there is a new vocabulary term today. So here's some things to think about. How can I identify patterns in the various representations we've talked about? We've talked about pictures, tables, graphs, and functions. And how can I tell that a sequence is arithmetic? Well, do we remember what is the difference between an arithmetic and a geometric sequence? Let's see. So an arithmetic sequence was either add or subtract at each step. Do you remember what a geometric sequence is then? It was multiply or divide at each step. So we're going to look at arithmetic sequences today, these ones over here. And we have this story. Scott has decided to add push-ups to his daily exercise routine. He's keeping track of the number of push-ups he completes each day in the given bar graph. So over here, you can see the number he's completing each day. On day 1, he has 1, 2, 3. Day 2, he has 1, 2, 3, 4, 5. Day 3, he has 1, 2, 3, 4, 5, 6, 7. And you can see that pattern continues each day. And it says after 4 days, Scott is certain he can continue this pattern of increasing the number of push-ups he completes each day. So first thing we should look at is, what is the pattern? So you can see here, this is going up 2 each time. So we're identifying the pattern in the picture here. This is going up 2 blocks. This is going up 2 blocks. So we would expect it to continue to go up 2 blocks every day afterward. So for arithmetic sequences, the number that is added or subtracted at each step is called the common difference. If it's subtracted, it would be negative. So the common difference in this case, what do you think it is? The number that it's changing by each step. So it looks like it's changing by 2 each time. So in this case, our common difference would be 2. If the pattern continues, how many push-ups will Scott do on day 10? And it says to model with a table, a graph, and an equation. Now this is interesting. We could write down the picture, right? We could just keep drawing boxes over here until we reach day 10, although that seems like it would take a while to draw those boxes. Maybe it might be faster with a table, a graph, or an equation. Any of those might be faster. So maybe let's start with our good old favorites, table and graph. Get my line here, because I can't draw straight lines. And a line here. And now we can do a table. Yep, there we go. Okay. So I'm going to do days over here and then push-ups over here. And we'll just number these out all the way down to 10 and see what we get. 6, 7, 8, 9, 10. So on day 1, we can just count over here. We have 1, 2, 3 on day 1. And then 1, 2, 3, 4, 5 on day 2. And 1, 2, 3, 4, 5, 6, 7 on day 3. And we did notice that these were going up by 2 every time. Up by 2, up by 2. So we could expect that same pattern over here in the table. Add 2 each time. Which means we're going to add 2 again here. And we go up to 9 for day 4. Add 2 again, and we get 11 for day 5. 13 for day 6, 15 for day 7, 17 for day 8, 19 for day 9, and 21 for day 10. 21 is our answer to that question. We solved it with a table. Okay. Well, once we have a table, it's pretty easy to graph that, right? We just graph these points. This will be our x value. This will be our y. Remember, y to the sky, and then x is the other one. So we will graph these points, x1, y3, that'll be right here, 2, 5, x2, y5, 3, 7, x3, y7. We keep going up by 2 each time. And notice we only got to 8 here. We'd have to keep going up. We'd go off this chart, off this graph. But we can draw, oh, this tool doesn't like drawing lines right where I want them. We'll try to draw a line through these dots. Pretty close through those dots. Let's see if I can get it right through. Not quite, but pretty close. So 10 would be somewhere up around here. That would be our 10 point and probably be about 1021, which is the same answer we had down here. Okay, so we did a table, we did a graph, we know how to do those things. But question, how do we write the function now? How do we write the equation? That's tripped us up so far. How do we figure that out? Well, let's try a really specific, explicit method. And we'll get there. Okay, so to write an equation for an arithmetic sequence, remember that means we're adding or subtracting, we need two things, the common difference and the value at step 0. Those are the only two things we need. So if you have these two things, the common difference and the value at step 0, we can use this equation. The function is mx plus b. Now, does this look familiar at all to anybody? Does this look like maybe an equation of a line we've seen before? This is what's known as slope-intercept form, because the m is the slope and the b is the y-intercept. So we can use this format right here, f of x equals mx plus b, where m is the common difference. Remember, this is the number that it was going up or down each time, each step, and b is the value at step 0. Interesting. So let's see how that would work. So here's our problem again. Let me grab a different color so I can write on that blue. Let's grab... Really? White is not a color? White would be so helpful. Okay, here we go. So what is the common difference here? So what is the change? Well, we decided that the change was plus 2 each time. So our common difference is 2. And then what is the value at step 0? Okay, so the value at step 0, this is interesting because we have day 1 here, right? Day 2, day 3. So to get to day 0, we're kind of going to have to go back 1 to day 0. We have to go step back 2. So that would be back 2, right? So we add 2 each day. So step 0 would have to have 1 block on it. So the value at step 2 is going to be just 1. Now what is the function? Well, we said we're going to use f of x equals mx plus b. We said the common difference is our m. The value at step 0 is b. And so we just plug those in. F of x equals 2x plus 1. That is our equation. Isn't that so much easier than struggling with it, trying to figure out what it might be? We just need the common difference and the value at step 0. So bonus question, how are the function and the graph related? Well, we did this graph earlier. We came up with this function. And notice, if you recall how we do slope-intercept form, this is the slope, this is the y-intercept, and look at this. We're going up 2 over 1, up 2 over 1, up 2 over 1, which tells us our slope is 2 over 1, which is 2. And then our y-intercept is where it crosses the y-axis right here. We call that b, and that is 1. You can see that on the graph right there. So if we were to write this in slope-intercept form, it would be, what? 2x plus 1. It's the same equation. It's the same equation we came up with that little rule before. And you can see that shows us, if we scroll back up here, that the common difference, the number it's changing by each time, is the same thing as the slope. And the value at step 0 is the same thing as the y-intercept. So that is everything for today. We just needed to identify the common difference and a corresponding function for an arithmetic sequence and write them down. And we will go over a few questions in the assignment so you get an idea of how to do those. Okay, so here is assignment 1.04, and let's do this first problem. It says evaluate each function for the indicated value. So we're going to take this -4 that's in for n, and we're going to put it in place of this n up here. So if I highlight this, -4, it's going to go in for this n right there. So let's do 5, and I'm going to put a -4 in for n, plus 8. We get 5 times -4 is -20, plus 8, and that equals -12 overall, so that's our answer. Let's do another one on this page. Let's do number 4. So once again, we're going to take this n and plug it in for n. Now notice this negative out front we still need to keep. That is not the n value. So this negative is out front, and then we're going to put n in. And n is -6. A negative of a negative is a positive, so overall this is going to be 6. Okay, so you can do those other problems on your own. Let's do one from page 2. For each of these arithmetic sequences, so it tells us right up front that these are arithmetic, find the next 3 terms, find the common difference, and write a function that represents the sequence. Okay, so we need to identify the pattern here. We have 3, then 7, then 11, then 15, then 19. Okay, so 3 and 7, well, that's going to go up by 4. 7 goes to 11, that's also going up by 4. It's going up by 4 each time. So what do you expect to be here? 19 goes up by 4, that's going to be 19 plus 4 is 23. Up by 4 again, that'll be 27. Up by 4 again, that will be 31. The common difference we identified was +4, it's going up 4 each time. And then our function, okay, now we get to remember what we learned today. It's going to be f of x equals mx plus b. We need to know m and b, so what was m? M was the common difference, and b was the value at step 0. Okay, so we kind of need to go up there and write which step is which up here. So here are our steps, and we can just say this first step is going to be 0, then 1, then 2, then 3, then 4. That's how ordering the steps works, right? We can just start with 0. So basically what we're saying there is b is going to be just the very first value. So overall here, we're going to say f of x equals m, common difference is going to be 4 in this case, 4x, and then the b, the value at step 0, is going to be 3. We got that up here. So 4x plus 3 is our equation. Remember, that came from mx plus b right there. And remember also, this was the equation of the line that this graphs. So that was number 7. And I'll let you look at this one. It's mostly just reading a graph. And we'll do one problem on this last one. Find the slope of each line based on the given representation. So we've got a graph here. And to figure out the slope on a graph, remember, we're going to start with a point that's at a cross section and go to the next cross section. So we notice this goes up 1, 2, and then over 1, 2, 3. Slope in a graph, slope is rise over run. So we went up 2 and over 3. That means rise over run is going to be 2/3 for this one. And I'll just give you a hint on number 15 here. Remember that the slope, which is what we're asking for, the slope is just the common difference. So if you can find the common difference in this one, you'll get the slope. And that's it for today.